A supernova is a powerful and luminous explosion of a star. It occurs during the last evolutionary stages of a massive star or when a white dwarf is triggered into runaway nuclear fusion. The original object called the progenitor either collapses to a neutron star or black hole or is completely destroyed to form a diffuse nebula. The peak optical luminosity of a supernova can be comparable to that of an entire galaxy before fading over several weeks or months. A type of 1A supernova happens when a white dwarf explodes. It is an extremely dense remnant of a star that can no longer burn nuclear fuel at its core, which our sun will turn into one day. In one type 1A supernova scenario, the white dwarf's gravity steals material away from a nearby stellar companion. When the white dwarf gets to be about 1.4 times the current mass of the sun, it can no longer sustain its own weight and blows up. Alternatively, type 1A supernova can happen when two white dwarfs merge. Type 1A supernova are special because the intrinsic brightness of each one is almost the same. They have been important in measuring how fast the universe is expanding. To end its life in a core collapse explosion, a star must be gigantic, more than 8 times the mass of our sun. As molecules fuse inside the star, eventually the star cannot support its own weight anymore. Gravity makes the star collapse on itself. A shock wave blasts outward from the core, and material from the star gets thrown out. This is how a lot of the heavy elements in the universe are created. Core collapse supernova are called type 1b, 1c or 2 depending on the chemical elements present. A non-standard supernova that doesn't fit into the type 1 or 2 categories is called a fast evolving luminous transient that is felt. In this case, a giant star burns out a shell of gas and dust about a year before exploding. Most of the energy from the supernova turns into the light when it hits the previously ejected material, resulting in a short burst of radiation. Scientists observe this brightening only over a few days, which is just 10% of a usual supernova.